A very good morning, good afternoon, good evening to all my dear friends, participants and students. Welcome to this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as all of you are aware, the basic three areas of coverage in this course: first forecasting, second regression, third is time series. And we are, as I said in the last 3 or 4 classes, at the fag end of regression and different models. So, this is week 9, 45th lecture, which will complete the 9th week, and we will have another 3 weeks to go. Each week left, as you are aware, would consist of 5 lectures each, and each lecture being for half an hour. Now, in the last class, if you remember, I dealt one lecture about different concepts of solving and trying to understand the models, which was the logistic model. And in the logistic in the probabilistic model and logistic model, which we will discuss. So, the idea was, given any set of variables x1 to xn or xp or k, as the case is, considering that we have k number or p number of random variables correspond to x, and you have y, which is categorical in the sense it is 0 and 1. And we discussed the problem that given a feedback of a restaurant, that how you can categorize what is the probability of you going there, based on the fact there are many characteristics of that restaurant which have been considered depending on the feedback which you get from different type of customers. Now, having said that, we will now go into another part of regression, which is nonlinear regression. Now, in the nonlinear regression, there are many tools, but I would not be covering all these things, because considering the 45th class, maybe to 46th and 47th, we will cover nonlinear regression, and then we would have another 13 lectures to finish for the time series. I know the coverage plan was in depth. We have tried to cover many of the topics in forecasting, so have we done in the area of regression, but still we should also have adequate time denoted or apportioned for the concepts of time series areas. Now, in a nonlinear regression, what is the idea? If you remember, in regression model, the idea was multiple linear regression, simple linear regression. The idea was to basically have a model where they are linearly dependent, the x and y, and there were some assumptions. Assumptions we have been discussing many times. We will try to keep those assumptions also valid in our case. Main thing, what is the assumption? We will discuss that within few minutes. Nonlinear regression is of the form as given here. Yi is equal to function of x and gamma are the parameters rather than beta, and you have epsilon, where the number of readings is 1 to n. Example of nonlinear regression is the exponential regression model of this form, very simple form, where you have the exponential form where there are 2 parameters, gamma naught and gamma 1, and the number of data points, as already mentioned, is 1 to n. Here, depending on the model, and if we have 3 different parameters, in this case it will be gamma 1 naught, gamma 1, gamma 2 parameters, and they are to be found out, and xi is the independent variable. The error is normal 0 sigma. We try to plot it out and show. Now, for our example, we have taken different type of nonlinear regression model, and I will plot it. Why? The reason is that will give you a good idea before trying to utilize some actual practical data from renowned textbook and try to solve them. So, I will go to the Excel sheet. So, the first model will be of this form, which is gamma naught plus gamma 1 plus x1 plus 1 plus gamma 2 x, and we will basically solve it accordingly. x1 and x2 would be the variables considered for the models. So, I will solve it a very simple model. What we are solving is we want to find out the gammas. So, I will consider nonlinear regression. So, this would be the nonlinear regression part, and we will consider gamma naught, we will consider gamma 1 and we will consider gamma 2. We will take the values as, say for example, 3, this I am doing arbitrarily in order to show 3, this will take as 2.5, this will take as 1, x values are here and we need to put the y values. So, I will take first the model here, which is gamma naught plus gamma 1 into x1 plus 1 plus gamma 2 into x, I will consider as x1 also, x2 also. So, here I will take x1 and x2 in very simple sense. And I am taking them considering numbers from, to make it simple, in the positive range. So, from 1 to 9 to 10, and here the values I will take as increments starting from, say for example, 20, and I will take them in increments of 1, so this goes to 110, and I will take here as, so this would be first numerator would be gamma plus gamma 1 into x, next would be, I should take here, let me check, and then I would wait, it will be 1. So, 1 plus it will be gamma 2 into x2. So, this is the value, wait, let me check. Oh, this is gamma 2 would be 313, my apologies, I took the wrong cell. So, this is 0.26. So, I will basically fix gamma naught, gamma 1, gamma 2. So, gamma 1 is naught is in cell A 313, I fix it. And then I take B13 also fixed, and then I go to C30 313 also fixed. So, the gamma values have been fixed accordingly. This will be 313, my yes. This is A13 plus B13. So, this will be dollar means to fix it, and this would also be 313. So, this will come, okay, now done. So, so let me check all the values have been done, I will copy it, and so these values comes out to be in this format. So, let me plot it in order to show. So, I have as two values. So, I plot with x1 and y. So, how does it the function look like? You can have an idea here. So, this is a nonlinear function of x1 varying along the x axis and y values. Now, if I want to have the look at how the curve behaves or shows up, considering I want to plot x2 values. So, this is also the same, but only the x axis is being replaced from x1 to x2. Now, I want to basically have a best fit. This is a very theoretical example. So, if I want to add the trend line, I am using the Excel one. So, there are different exponential part is there, and wait, let me move it on to the right and let me make the series markers as black. So, it is easily red one is easily visible with width of 3. So, this is done. So, this is the line which I have for the exponential linear part. This is the exponential part if I have. So, this exponential part, this is the logarithmic part, this is the exponential part, this is the polynomial fit, this is the power fit and the moving average. So, if I check the exponential part or the polynomial part, I display the equation and find out the R value. So, let me bold it. Why R square value? Because that will give you the best fit. So, this is the equation which you have, which is fitting, but if you check the equation, we have utilized the based on the equation which is of this form. Now, R square is about 95%, which looks good, but the trend if you fit it, it's definitely not give you a immediate level of satisfaction. Now, what is important is here. If I go back to this PPT slide, so there are many different type of nonlinear regression, which I will discuss one by one depending on the modules, and I will tell you the. So, this would be, let me go back. So, the first equation is that I am only taking 1x, it can change depending on that. So, the second equation is this one. You have gamma 1 into x to the power gamma 2 plus epsilon, where the powers of x are being multiplied by gamma 2, which is a constant parameter based on which you have to find out the best fit line. What is the best fit line? I am going to come to that. Then you have the equation y is equal to gamma naught plus gamma 1 exponential e to the power minus gamma 2x. Again, this is a nonlinear form, but it is on a decreasing format. Here, as x increases, gamma 2 being the value, so obviously you can have an increasing function of x if gamma 2 is more than 1. In the third equation, in the fourth equation, you have gamma 1 plus gamma naught plus gamma 1 x plus gamma 2 x square. This is the numerator, and in the denominator you have gamma 3 x plus gamma 4 x square plus gamma 5 x cube. Here also again only 1 x, but now it is in the order type. If you see in the numerator you have till the square term, and in the denominator you have till the cubic term. So, obviously, this is a nonlinear equation. Again, what it should be found out is the best fit line, and how you want to find out the best fit line, we will come to that. In the second last equation, it is of the logarithmic form. You have gamma naught plus gamma 1 ln x plus gamma 2 ln x square in the numerator, and in the denominator gamma 3 ln of x square plus gamma 4 ln of x cube plus gamma 5 ln of x 5 is also of, or in the later part it is in the denominator is order 4 and in the numerator is of order 2, and based on that you find out the equation. Then in the last equation it is of the logarithmic form, y naught plus y 1 ln of 1 by x plus gamma 2 ln of 1 by x square in the numerator, again square terms till maximum value, and in the denominator you have square terms multiplied by gamma 3, cubic terms multiplied by gamma 4 and 4th power terms multiplied by gamma 5, again it is the maximum power is 4. Now, what is to be found out? We will come to that. So, let us consider, I am going to directly for the problems. Let us consider a problem where you have the values of x are given in the first column and the third column, and the corresponding values of y are given in the second column and the fourth column. So, you have x as 2, the y value is 54, then x as 5, y value is 50, so on and so forth. And the values are there and I want to plot them. So, I plot it. Now, what is interesting is here, and based on that I will come back to the data set which is there. So, here the y versus x values which I plot, and I plot the violet points are the bullet points are the actual data points and the red line is the best fit. So, what is very interesting is from this you get a quadratic function, and of the form, if I consider the constant term is 55.822, and then if I consider this as gamma naught, then gamma 1 is equal to minus 1.7103, and gamma 2 term, which is the term parameter term being multiplied with x2, is 0 plus 0.0148. And interestingly, the r square value comes out to be about, I will use a different color here, comes out to be about 98%, which is quite high. Now, the reason is that you can basically experiment with the data set of points to find out which is the best fit line, and I will do that accordingly in this problem. Problem is the data set which you are talking about. So, if you see it here, this is the data set based on which we think would be the best fit. Now, let us find out the values of, so I change and find out, consider these are the theoretical values of gamma. Now, what I need to do is I find out y hat based on change values of gamma, and let me do that. So, I will keep gamma 1 and gamma 2 fixed and gain change gamma naught. So, this is equal to equation being, so here I will have the values, I will take the values from here. So, here it was given by gamma naught into, so I will copy it here. So, this was A naught, so these remain same, I have to take x values. So, x values are here. So, now I change gamma naught to 2.5, wait, let it be 3. So, I have these values, I copy them, then I find out a value of gamma naught changing to 2.5, I find out is to be this, wait, and increase the decimal level to 4 places of decimal. So, that 5 to, so that will give us better idea of the error. Now, what I do is that with change value of gamma naught, which is to 2.4, 2.5, I have a new set of values here, I will paste it here. So, that value is changing. So, this is why, consider these are the actual values. This is y hat 1, 1 means for the first instant. Similarly, I will have y hat 2, so this I change now gamma, this I make 3 and gamma 1 I basically decrease to 2. So, these are the values based on one change of gamma 1. Again I copy these values. So, here I go back to 2.5 and this gamma 2 I change to say for example 0. So, if I change to 0, let me change it not to 0 because I am changing the quantum should be of 0.51, I decrease it. Yes. So, now I have error 1 which is based on only change of gamma naught by 0.5 decrease. Error 2 I have is only change in the values of the actual and the estimated value based on the fact only gamma 1 is changing by 0.5 units. And finally, I have error 3 which is the difference between the actual and the estimated value based on only gamma 2 changing by 0.5 units decrease. So, I plot the errors. First, I find them, actual value minus the hat value, actual value minus the hat value. I copy them for all the values. So, I will only plot the errors first. So, let me check whether I have done it for 3 decimal of places. So, that would be better for 5 decimals, we are doing the 5 decimal. Number, then make it 5, done. So, I plot the errors as data points. So, this should be in the chart format to give us all information about this is for error 2 and error 3. So, actually it should be error 1, 2, 3, but marked with the data point size. Yes, no, my mistake, both should be considered. Yes, all data points done. So, 91 data points. So, I plot it and here you check how the errors match. Now, if you check the orange and the blue one, so let me change the color. So, it will make much more contrasting comparison color wise. So, you will get an idea. Let me make it red and the blue one changes to violet and the gray one changes to green. So, now you check. So, for the error part change, why I am showing that if for the error part 0.5 change in one value beta naught or 0.5 change value in beta 1, the error part is not that much like with 0.5 error change in this beta 2, which means that you need to find out number 1 the rate of change of the function, which is based on the fact that what we have been doing in the multiple linear regression, number 1, and number 2 why I plotted it is that it gives you an idea that whether the error is decreasing or increasing. So, in the real sense error should be minimized always, and that is the crux of the matter. Now, why did I go in drawing the diagram and trying to not go back into the calculation first? If you remember, in the nonlinear regression part, if when I go into the next class, trying to differentiate and put the error as 0 would not give you closed form solutions of betas, as it was the case for the multiple linear regression. Hence, I took a detour in order to make you understand that how number 1, each parameter which is being changed by 0.5 units, that will give you the rate of change of that parameter keeping other constant. So, in the partial derivative sense you will get the idea what is the change, number 1. And number 2, that if the error is important, how do we keep and minimize the error based on the fact that you have now a nonlinear regression part. We will come to these solutions in a very simplistic sense and discuss them with examples in the next class. Have a nice day and thank you very much.